Graphing linear inequalities. The first thing you always want to do is make sure the equation is in y equals mx plus b form, which is the slope-intercept form. M is your slope, b is your y-intercept. Since our equation is already in that form, we can go ahead and identify what our y-intercept is at -1, and our slope is at 2/3. It's a positive slope, so the line should point up on the right side once we graph it. A few other things that we have to look at. Our inequality is less than, so that means we are going to have a dashed line, and we will shade below the y-intercept. Okay, so we're going to start with our y-intercept, which is at -1. Our slope is positive 2/3. So I'm going to go up 2 and right 3, up 2, right 3. I'm going to go down 2, left 3, and I'm just going to extend this 1, 2, 1, 2, 3, just a little bit further so it's easier for me to make my graph since I don't have a ruler. So it is dashed. Make sure you put arrows at the end of each, at the end of the line on each end. And then we have to shade. So we want to look at less than our y-intercept. So our y-intercept is right here at -1. The y values that are less than that would be below. So we are shading the region below. This equation is in standard form. We want to change it into slope-intercept form. In order to do that, we need to get the y by itself. So if we subtract 9x from both sides, we get 12y is greater than or equal to -9x minus 60. And then we would need to divide by 12 to get y by itself. And just a reminder, we just divided by a positive value. If we had divided by a negative value, you would have to change the inequality sign to less than or equal to. Simplify our slope, so -9/12 would become -3/4 x. And then 60 divided by 12 is 5. So there is our slope-intercept form. Y-intercept is at -5, and our slope is at -3/4. And then let's look at our inequality sign. It is greater than or equal to, so it is solid and above. We'll shade above. Okay, so -5. 1, 2, 3, 4, 5. So -5. And the slope is -3/4. So that means it points down on the left. So starting at the y-intercept, I'm going to go down 3, and then I'm going to go right 4. 1, 2, 3. And we have a point right there. Since I can't go down and right anymore, I'm going to go up and left to draw in our line. 1, 2, 3, 1, 2, 3, 4. Okay, and so now I will draw in the best I can our solid line. To shade, we are going to shade above our y-intercept, and so that would be above our y-intercept. And I just noticed I had a spelling error right here. That should say shade. Whoops. Fix that. Go back to my pen. So this should say shade above. All right, graphing a quadratic function. So I'm going to show you two ways. This first way is using the -b/2a, which we want our equation in standard form, which is given. And you can see I have written the values of a, b, and c. Using negative b over 2a, we have the negative, and then b is negative 2, and a is 1. And so if we clean that up, that's going to give us a value of 1. So there is the x value of our vertex. To find our y value, we plug it back into the function. So we have x squared minus 2x minus 1. So I'm going to plug 1 in to each of these terms for x, and then calculate. So we have 1 minus 2 minus 1, which gives us negative 2. And so there's our vertex. I'm going to plot my vertex at negative 2, or I'm sorry, 1, negative 2. Draw in my line or axis of symmetry. Sorry, my line's not so straight. And then we will, from there, plug in two values to the right of 1. So we'll have 2 and 3. And you're going to do the same thing like we did up here. So if I say x is equal to 2, then I'm going to have 2 squared minus 2 times 2 minus 1. So that's 4 minus 4 minus 1, which gives us a value of negative 1. And then if I plug in 3, I'm going to get 3 squared minus 2 times 3 minus 1. So that is going to give me 9 minus 6 minus 1, which is equal to 2. Now if I continue to plot these points, I have 2, negative 1, and I have that reflection point, and 3, 2, and that reflection point as well. Oops, wrong spot. How about we go right here? Okay, so before we graph this, we need to decide if it's solid or dashed, and it will be solid because it does have the equal sign under it. So I'm going to do the best I can in drawing this in. And then to shade, we are going to shade below because we have a less than or equal sign. So here's my y, so I'm going to shade below. Okay, this last example, we're going to complete the square. I'm going to refresh your memory on how to do that. Remember, you want to separate your variable terms with your constant. And once you do that, you can complete the square. So we're looking for this value right here within our quadratic function to make it a perfect square trinomial. So we take half of our b value, which is 2, and then square it. So 2 squared is 1. In order for our equation to remain balanced, we need to subtract 1 with our constant. Once we have that, we need to factor our perfect square trinomial, and that factors to the quantity of x plus 1 squared plus 3. And now we can identify our vertex by looking at our h and our k. So our vertex would be at negative 1, 3. And then I'm going to pick my 2 points to the right, so I have 0 and 1. If we plug in 0, we get 0 squared plus 2 times 0 plus 4, which will give us a value of 4. Now if we plug in 1, we'll have 1 squared plus 2 times 1 plus 4, which gives us a value of 7. So we have our points. We can now plot our y, or our vertex at 1, negative 1, 3. And I'm going to draw in my axis of symmetry because that will help me get 2 additional points from what I already have. And so 0, 4, and then it will reflect. Our next point is 1, 7. So let's see, 4, 5, 6, 7. And then we're 2 units away from the axis of symmetry on the right, so put 2 units to the right on the left. We have a dashed line, so that means we connect with dashes. And again, remember to put arrows at each end. And then we need to determine where are we going to shade. So I'm going to locate my vertex, and it says that we have to shade above. So above my vertex would be within this parabola.